Hello, everyone, and thank you for joining today's webinar. My name is David Green. I'm the marketing manager here at IDERA, and I will be serving as your host for today's event. The topic of this event is Uncovering Hidden Performance Bottlenecks, a deep dive into SQL Server. Joining us today as the presenter for today's event is industry legend Pinal Davi of SQL Authority. Before I hand things off to Pinal to start the event, I would like to take a moment to remind you that we'll be hosting a short Q&A after the event. To this end, we ask that you direct any questions that you may have during the course of this event to the questions panel. On a final note, this webinar is being recorded and will be available to view on demand after the event has concluded at any time. With that, we're ready to get started. Pinal, you have the floor.
Fantastic. I think one thing in all this is that thank you very much, Team IDERA. You guys always awesome and hosting this one. And within a second, my screen should be visible to all of you. So thank you. So thank you, David. Thank you, IDERA, for having me here. And welcome all of you guys here. And we are going to make a very interesting session. This will be a little fast-paced, but my request to all of you is that at any point of time, if you have any question or any comment, you can just paste it in a question and answer window. I like to answer your question as they come in. So don't hesitate and just write it away right away. It doesn't have to be question. It's just way to communicate with each other, right? So that's the goal. That's what we want to do. My email address is on the screen. So if you have any question afterwards, or if you're watching this webinar later on, you can always reach out to me. You know, you guys, a lot of you are right now live, but I know a lot of you also watch it afterwards. So if you're watching it afterward, well, you guys are welcome too. And yeah, let's get started with the very first concept. So, you know, what is hidden performance bottlenecks? Like what stops us? Let's talk about this thing. I don't want to talk too much theory. I think it would be just fun if we just start with demonstration. So how about that? This is the very first demonstration, and I'm enabling the execution plan. Hopefully the screen is clear to all of you. If not, just let me know. I have already zoomed out things. Now, I have a question for you guys to participate. Is the icebreaker between you and me. We want to be friends. We want to be together, right? We don't want to. I don't want you guys to just sit there and just listen me. We don't want to do that. So look at these three queries. These three queries return identical results. Now, my question to all of you fine folks is, which one of this do you guys think will be the most efficient? Let's see, what do you guys think? You can say left join, not exist, or not in. You can write in a question window. That's totally fine. I read it. And, you know, this will be fun to do it. Don't be lazy. Uh, let's have a good conversation. And you can also write directly chat to me. I mean, if you just don't want to uh, just put it out. Sometimes people ask, like, oh, I don't want to put it out on a question answer window. I want to write to you personally. Then you are welcome too. But I would rather prefer that you guys just put that thing in the questions and it will be fun. So which will be the most efficient? The left join, not exist, or not in? All three actually are identical. Isn't that fun? This is interesting. This kind of question I love, because let's figure it out by just running them. I'm running this thing for AdventureWorks. I've already turned on statistics, IO, and time. And I like you guys are so enthusiastic. So many of you are making guess. Some of you are writing in a parenthesis as educated guess. Well, that's all welcome. Even educated, uneducated, or just blind guess, you know, everything is welcome. Now look at the execution plan. And here's the answer for us. The first one query cost is 78. The second one is 11. And third one is 11. When I scroll down, you can see both of this execution plan, both of this queries execution plan is identical. So what it tells us that not exist and not in right now performing exactly the same. You know, we learn this thing. I mean, I read the books, I read online, I watch sometime videos also, and people say never use not in. Sometimes not exist is better. You know, it's sometimes. SQL Server Optimizer is smart. It knows what to do. It sometimes automatically fixes them. As you can see, not exist, not in, both of them are giving same performance, 11% each. And look at the 78%. Looks like left join is the most expensive, isn't it? Yes or no? All right. Okay, because those who said left join, I think left join got the most votes, and that's good. And if you're watching it afterwards, it will be fun for you. Yeah, just to add you, if you were thinking left join would be most efficient, well, that's what everybody online right now said. So we are all in the same boat. But is it true? Well, in terms of query cost, it's not. But is it really? Well, that we can only figure it out when we check the statistics IO, and statistics IO tells us interesting story. In terms of IO, the first query has logical read of 339. Very, very little, very, very small number logical reads. And look at the logical read for the other two queries. The query number 2 and query number 3 has 1090. That's almost 3 times than the first one. So if you are looking at IO reads, then the first query is the most efficient query, and that's it. If you have IO pressure, then the first query is the one which is actually the best. But if that's not the case, then let's start digging little deeper. Okay, look at this one. This query has a CPU time of 47 and elapsed time of 273. So definitely it is slower. So if you want query to run faster, well, look at the second option which we had, where elapsed time is 128, almost one half of this one, and CPU time is next to nothing. But it did take a lot of reads. So if you want your queries, right? If you want your queries to have less amount of time to run, then definitely the second option was better. In terms of the third one, same IO, but look at the elapsed time is even lower. Now, the reason here is that because when we look at the query, well, for this particular query, left join was most efficient in terms of IO, but it took way more CPU and time, whereas this one was good in terms of time, but not in was the fastest. Now, that tells us that when you check the query, just don't go on an execution plan. Always look at statistics IO and make your decision. Because this kind of hidden things is what we want to know and make decision. So if your IO is super, super slow, then this would be even slower because reading this much data would take way more time. But in my case, IO is awesome. It's really fine. That's why it took way less time. So what is your crunch? What is your pressure? Where you are struggling? Are you struggling with IO? This is the best. Are you struggling with the time or CPU? Then, this one is definitely worse. But look at this one is much faster in that way. Okay, couple of people are asking question. Don't you think so? The query is returning the result faster because of the data is from the cache for second and third query? No, 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 no. That's not the case. Look at the queries are different. Every query has their own cache. Even if I put a space over here, or if I just change small p to capital P, and this kind of thing also matters, and it will have its own execution plan, its new cache, and everything. So yeah, it's not cache. Cache doesn't play at all over here. Now, if I run it even second time, like, okay, all right, 3 or 4 of you guys are saying run it again. Let's run it again. You'll see little different numbers. Definitely query cost won't change, but you can definitely see logical read is still same. IO part is little faster because of caching, but look at the time is still in a same proportion. First one took a lot of CPU time, and the one after that doesn't take any CPU time at all. So yeah, this is how you can design your queries. This is what you need to know when you are actually tuning your queries. You should be careful with what kind of resource you want to save or optimize. Well, if I have trouble, this is the one. This is the one example. Now, let me just take it to a second similar example. Here is my another query. This is again a very interesting query. Look at this one. And can you guys look at this? And the first one is a simple query. Second one, where I say option fast 100. And third one, where I say fast 1. Now, what I'm going to do is I'm going to enable the execution plan, run all these 3 queries together, and let's see. Okay, I'll give you a moment to think. I'll give you a moment to think right now. The queries are there in front of you. This is the execution plan. Have a brief look, but I would definitely first go to execution plan. Execution plan is there in front of us. Now look at this execution plan. I'm going to go little silent for a second because I want you to pay attention to this detail about query cost. 97, 2, and 0. Well, when I look at the result, it's identical. Result is identical. There is absolutely no difference in result. However, execution plan has a huge change when I provide this hint. Don't you think so? If that's the case, I should always provide option 1, option fast 1. This hint, if I provide it, all my queries will have a very little query cost. Is it true? Well, answer is in the messages. If you pay attention over here, it is very, very clear to us at this point of time that query number 1 definitely took little more time, but has least amount of the CPU. Here, query is little faster, but taking more CPU. Query number 3 is the fastest and takes most amount of the CPU. What about IO? Well, query number 1 once again have the least IO, where query number 2 and 3 has huge amount of the IO. So if your IO is slow, these two query would have gone for 10 seconds, 20 seconds, 30 seconds, actually. But my IO is very, very fast. It's SSD. That's why you don't see any difference at all. This kind of bottlenecks, which we have to understand. So during the busy time, when your CPU is under pressure, this particular query, the last one, will take more CPU and will get even more slower. Do you want that? No. We want our query to run fastest. So always make sure that you check the execution plan, and along with that, check the statistics, IO, and time. These are the 3 things you must look at together if you really want to do performance tuning. Because if you don't do that, then you face a problem. Like, you will be deceived. Your execution plan will lie to you, will misguide you. This kind of thing can happen. That's why always use these 3 things together. All right, question for you guys. Did you guys like this presentation so far? Do you use this kind of hint in your business? I mean, like sometimes people use hint. Like one of my clients came to me and said, I figured it out how to run each of my query fastest. And I was like, how? Put option fast 1, and now your queries will run amazingly fast. And I was like, really? They showed me this and said, look at that. And I was like, honestly, it looks like it is running fast, but it's not. There are many problems. Matter of the fact, the first query took the most amount of the time. All right, few of you have already asked me why the first query is taking 97%. The answer is, it is because it is using hash match. See, SQL Server thought I'm going to get a lot of rows, around 121,000 rows. So it built the execution plan for 121,000 rows. Here, it thought I'm only going to get 101 rows. That's why it built the execution plan for 101 row, which is with a nested loop. And actually, nested loop is very, very poor for this kind of execution. And that's why even the query cost looks efficient, but real cost is crazy bad, crazy bad. Yeah, that's how it is. And also same goes with the third one. Like when you have a fast 1, SQL Server thought, I'm going to get you 1 row. Here its estimation is 3. And then it ended up retrieving 121,000 rows, and it has to loop over each of those rows, and the cost goes very, very high. And this kind of hint, right? One of you are saying this kind of hint are available in some of the tools right out of the box, which is sometimes provided by various organizations and third-party tools. So if you see hints, and just make sure always go and check the statistics IO. Hints has a habit about to slow down your performance. And that's what I keep on talking about. Like, what's the point? Who is actually slowing you down? This kind of hidden performance bottlenecks slows you down. They are there everywhere in your code, and you just do not know. Now, here we have just one or two query, right? These are the queries which we have. So I know how to tune this kind of queries, but honestly, this is not the case. Sometimes you just have to monitor a lot of things together. You have to monitor hundreds of the queries, and then after find this kind of troublemakers. How can you do that? That we will talk about little bit later on. My friend David will explain you before the end of the day. But just right now, focus on learning about what kind of things which can actually slow down. You may just pay attention to execution plan, or you may just pay attention to the logical reads. You may just pay attention to one or two parameters. Actually, comprehensively, all of them together plays a vital role based on which of the resources in your system is highly used or abused, or however you want to put it. And that's what it is. All right. So I think this answers every question so far which we have received. Let's go to the next demonstration. This is more fun one. This is more fun one. All right. So what I'm going to do is that I'm going to run an identical query. This is the same query. I'll run it again, again. And only change among all these queries is the compatibility level. The compatibility level 160 stands for SQL Server 2022. Compatibility level 130 stands for SQL Server 2016. And compatibility level 120 stands for SQL Server 2014. Now, whenever you upgrade your SQL Server database compatibility remains as it is. They don't change it unless you go and manually change this compatibility level. Now, here, watch what happens when you change the compatibility level or do not change it. So I'm going to run this entire query together with execution plan, and I want to show you this trick. After watching this trick, you may not hire me for performance tuning, because when I go for performance tuning, this is the one of the first three things I go and check it. Because if this is one of them, I know what to tell to my client and how they will get the better performance. It's super easy after this, extremely easy. So that is compatibility level. And I will show you how you can do that with SQL Server Management Studio. But here I got three identical results. Now, before we see the message, I want to show you execution plan. And this is going to be fun. Look at this first one. The same query is there. In the very first query, where I have a compatibility level of 120, that means even though my SQL Server is SQL Server 2022, you can run with compatibility level of 120, which is 2014. So, it's like having newer hardware and running your system with older OS, something like that. So now when you go to execution plan and see over here, the cost is 48. But more than the cost, pay attention to the kind of the join. The join says it's merge join. That's it. It says merge join. Merge join is kind of a join, kind of inner join, where both the side of data is sorted and then compared and everything. But that's kind of join. But SQL Server decided, as it moved forward from SQL Server 2014 to 2016, it decided maybe for this query, the merge join is not optimal. What did it do? It changed that to hash join. Now, SQL Server thought hash join, which is internal physical operation, is much better for this kind of logical operations. Well, SQL Server thought that's best. But is it really? Well, as we move forward, we came to SQL Server 2022, and SQL Server has the same query, but this time just go and check this execution plan, and we see a new thing. It says it's called adaptive join. And it is actually using nested loops. Look at that. A same query which has a same query which has three different kind of joins in three different kind of compatibility level. That's really insane. So which one is right one? So that's exactly the point. When you upgrade your compatibility level, you might start getting the right one. For example, for this particular query, merge join is optimal. And for this query, the hash join is optimal. But ideally, if you come to this particular query, SQL Server thinks the nested loop is optimal and it has selected the nested loop. And the reason why it is called adaptive join, because if we change the parameter, SQL Server will happily change that particular parameter internally. It will not cache your execution plan as such. And it will say, fine, if I have to change my execution plan, I would definitely go and do it. So for first one, it still remains as a merge. For second one, it still remains as hash. But for third one, SQL Server said, you know what? When you change this particular parameter, at that point of time, the hash match is the best one. SQL Server is very, very adaptive. SQL Server could go and change its algorithm dynamically. Did you guys see the impact of adaptive join? It doesn't get stuck. It moves. It actually adjusts what your parameter is and what is the algorithm behind the scene, right? This is the power of the latest version of the SQL Server, and this is the power of the latest version of the compatibility level. And that's why it is important that you go and check what is the compatibility level of your database tool, because it's quite possible you might be still running older compatibility level, and that might not be the best for your database system. So here, when you go to database, you can go to database properties, and over here, you have a compatibility level. Here, if you are on a latest version of SQL Server, and if you have this particular compatibility level little bit older, then there is a problem. So yes, so that's where you need to check it. Now there are some good thing and bad thing about it, and I'm going to write on a screen so we can all read it. There's a warning which I'm going to write it. So yeah, and a couple of you folks are asking, is adaptive join there in SQL Server 2019? Yes, it is there also. In 2022, it works much better, but it is still there in 2019. But for that, you need to have your compatibility level at this point of time. I mean, it should be set to 2019 or 150. Otherwise, it won't work. All right. So there are three questions which you guys have clearly asked, and I'm trying to answer each of them. So the very first question, I think somebody asked me, is that if you upgrade, if you go from if you go from 2014 to 2020, can you downgrade? First of all, this is not upgrade or downgrade. This is just changing compatibility level. So you can always go up and go down. Absolutely no problem. That's the first thing. So this is one thing. You can go up and go down. No problem at all. This is flexible and you can do that. The second question which I have is, if I have SQL Server 2019, can I set compet level to 202? No, no, you can't do that. You can only go down, you can't go up based on your version. That's one. Third question which I have received, because I'm just trying to collect all these questions and answer one together. So that was first. This was second. And third, any negative impact? Great question. So sometimes you get some queries running slow or regression in query performance when you change your compet level. If that really happens, then you can go up and down and select the best possible one for your system. And that's why it goes without saying, test everything on dev first with real life workload. All right. The reason I type it out, because so many of you asked this question, so it's important that you guys read it. When you read it, it's easier to digest. I hope this is now clear based on all of you those questions. All right. So let me answer a few more questions, which is just come in. Is the cardinality estimation will affect, well, when you change compatibility level, yes, it will be impacted. Is SQL Server 2022 stable? Absolutely. Many of my clients are using it. Very, very stable version of the SQL Server. So you can definitely go and use it. What about backups? Backups just works as they work. You don't have to change anything in that. So if you go back to your older compatibility level, will it pick up the older plan? Most probably. Most probably it will pick up the older plan. And yeah, there is a one more question which is in asked in detail. I'll try to read it and we'll answer it a little bit later on. So, so I guess these are the most questions I've answered. If you have any other questions, please ask me. This was a fun demo for me, and this is one thing I want to talk about. Like a lot of time we spend time with the indexes and query rewriting and whatnot. But the real problem lies in compatibility level because we haven't set it appropriately for our workload. Why don't we just go and do that? Yeah. All right. So fine. Did you guys like this one? That how compatibility level plays a role and introduce a new enhancements in your SQL Server, and how SQL Server is smart enough to decide which kind of join it should be using it. Like, look at this. Here it decided, right? I mean, for this parameter, this is better. For another parameter, that one is better. So let me just run this thing back to back, and I think you will understand the impact of it. So what I'm going to do is, this is it. So these are two different parameters, and I'm going to run it together with compatibility level. Definitely will sit the 160, which is latest one. Let's run it. Look at the performance is actually equal, but SQL Server does its own magic over here. Here you can see it's a hash match. Hash match. It will be visible. And here you can see it is nested loop. SQL Server took your parameter and did its own magic. So that kind of thing. So new enhancements and all of this, you can use it if you are on a newer compatibility level. But once in a while, as I said, there will be regression. So it's always good idea to just check it out. Yeah. All right. So, and all right, this is done. There is one interesting question I want to answer. What will be the best to consider? Is it logical reads, CPU usage, timing, or cost? Well, what do you want most? You want your, if you don't have enough CPU, then you just have to consider that as the best. If you don't have enough reads, then you should consider read as one of your priority thing. Always optimize for the resource which is not available easily. That's it. So yeah, that's it. Okay, time for next demonstration. And this is also related to the compatibility level, and it's fun. All right. So I showed you a query, right? We just ran this query for compet level 160. Let's just run this particular query. All right. Oh, I forgot very important thing. Any of you ever forget like sometime to just run the use database, run the query, and then realize, oh yeah, I missed it. Does it happen to you or is it only me? All right. I rerun this query. Let me just rerun this query. Okay. And then we'll check the execution plan. Okay. Fantastic. I want you to pay attention to this particular warning. Yeah. Or I like one of the answer. One of you are saying that this is how we all create many objects in a master table. Agreed. My master table has a lot of objects, so I always go and check it. That if accidentally I've created anything, I will go and drop it. Now, look at this particular warning. This particular warning tells us that this particular query, this query has excessive grant. Query looks very, very simple, but it received 61 megabyte. It says 61 here. I just put accidentally this. And how much it used actually? 480. So out, out of 61 megabyte, it only used 480 kilobyte. If I run this particular query 10 times in parallel, you know what would happen? They will take 610 megabytes. This query is very expensive. Ah, my English. Yes. This query is very, very expensive in terms of memory. We cannot run few of them together. What should we do? What should we do in that case? Well, I'll tell you the answer. Look at this query, 61 megabytes. Now, I'm going to rerun this query. Just watch. Let's go back. What happened? Now it's only taking 372 kilobytes. Wasn't the same query previously taking 61 megabytes? From 61 to 30 and 72, how did that happen? How did this thing happen? Well, that's the power of memory grant feedback in SQL Server. So SQL Server, when you use the latest compatibility level, SQL Server is very, very, very smart. It knew itself. When you run it first time, it immediately knew that you are taking way more memory, and that's not a good thing. And it decided that, all right, you're taking way more memory, not a good idea. So I'm going to learn myself. In terms of join, it learned. But in terms of memory, it has also learned and said, you know what? I know I don't need that much memory. I'm going to reduce the consumption of the memory when you subsequently run it. This is all because of compatibility level. So if you are running this thing, like for example, if you run this for older compatibility level, then the same error you will keep on saying again and again. You can run the same query multiple times and you will still see the same kind of memory grant. But when you just move them up and taste it, and suddenly you have more memory. I have a few of the clients, right? That's what I'm saying. I have many clients, they said, we have trouble of memory, we have trouble of CPU, we have trouble of this, we are just running this problem, that problem. And then we just go and like, okay, let's check it. Can you run your dev system or development system few times on a SQL Server 2019? or 2022. Can you run it? And they said, sure. So once they run it on any of them and 1 week, and then they move to the production, and suddenly they're saying, "Oh, suddenly our queries are running much faster. We don't have a memory crunch. This is all because SQL Server has already inbuilt smartness in this program, and we just don't take advantage of it." So my suggestion is that don't hire expensive consultant like me. You don't need it. You can just change this thing on your dev system, run this for a while, and you can find the hidden troublemakers, and you can just get rid of them easily. That's what it is. And after doing this, if you still have a problem, then there are ways to monitor it, and we'll talk about that in next 10 minutes. So don't worry. I'm just talking about how about we take care of the low-hanging fruits first. This is the low-hanging fruits. You just take care of it, your system runs fine, and then after, we look at the other problems which you have. But just make sure you test it properly. Just don't blindly upgrade it. Blindly upgrade would just put you in a more trouble. And if you're ever going to do that, then I suggest you definitely try third-party tool along with it, so you know where you are making mistakes and not. But we'll talk about that a little bit later on. I hope you guys have got this particular idea that how powerful newer features are and how we can take advantage of that if we just change the compatibility level. Any other questions you guys have so far? I really like it what you guys are asking, and I'm trying to answer all of you. Some of you are asking, is memory grant feedback is in 2019? It is there. It is definitely there, but it's much improved in 2022. See, everything in a 2017 and 2019 was the V1, V2, and as we move forward to later version of the SQL Server, they really did better, much better. So that's the entire story. Now, I think it's time when we see another interesting demonstration. Do you guys want to see one more demonstration about, how things which are hidden but in front of our face, but we are not able to just find them. We are not able to see them. Sometimes things which is in front of us, we just don't see them. And they are the one which are actually real troublemaker. Let's see how we can do that. So I'm gonna do, okay, few of you are saying you want to see the demo. Sure, we'll do that demo, no problem. So I'm going to create a table which is called orders, nothing much here. Table I just created. Okay, now I'm just seeing the data in that table. Nothing to take home, anything, simple data. Now I'm just creating index on this particular column, which is reference number and including amount. Just creating it. Now the fun begins. Can you guys tell me, this is my last question to you, so please participate. You are over 500 of you folks there, and so many of you are watching offline. So if you're watching offline, please make a note on Notepad by pausing this video, because I want you to take a shot at the answer. If you say it in mind, it's sometime, oh, I was about to say this, I was about to say. So my question to all of you would be, which one of this query will be most optimal? That's the question to you guys. Which one of this query will be the most optimal? Do you think the query number 1 or query number 2? This is the last question. And I'm not going to publish your answer to anybody. It's just for our conversation. You and I, we are friends, we are together. Now at least been talking for a while. At least, we can have a two-way communication. Otherwise, anything online can be boring. We don't want to make it boring. So we want to make it interactive. So I give you the last 10 seconds. Okay, I'm going to count 1 to 100. And by that time, you can put your answer. So I'm going to start 1 to 100. That's what I said, 1 to 100. So let's try. All right. So I'm going to check the execution plan. Absolutely. Most of you have guessed it incorrect. Except 2 or 3 folks. Rest of you all said the first query will be the most efficient, whereas the second query will be the most expensive. But answer is actually, yeah, very different, isn't it? I thought this would be the faster, this would be slower, this is integer to integer matching, and this is a string to integer, so string will be converted and all the things which I learned in a book. Yeah, and look at that. The first one has actually interesting warning. And when you read the warning, you will figure it out the answer. It is saying that cardinality estimate is an issue and there is convert implicit of reference number to integer. Somehow reference number looks like not an integer and now it is being converted to integer. That's why there is a convert implicit and that is affecting seek plan, and it's not seeking actually, it's scanning. You can see scanning. See, this kind of thing we need to know. Running simple query is not important. We just need to know what is going under the hood, hidden things. And those are the things which we need to find from our system. So what's the trouble? Well, reference number is varchar. Oh, I'm not so smart. I think I should fix this thing. I should do a right presentation. So I'm going to change the reference number from varchar to integer. But for that, first I need to drop the index, convert them. So I'm converting it. It took time creating the index back so we can compare apple to apple. Now let's rerun those two queries. This time I have a question for you. Now this is integer. This is integer. Both are integer. Which query will be the fastest? Let's have a final answer. One final time our conversation before we see something more interesting. All right. I'm going to give you some seconds, you guys. Come on, we are friends. I expect some more conversation here. All right, good then. Fantastic. All of you are right. Anybody who is answering one are right, and anybody who is answering two are also right because both of these queries are actually equal. They are same. If you guys thought this would be this would be 1 and second one will be 99, no way. Both are same. So whatever you answer, you would be right. See, I can't let you be wrong. You are learning with me. You are my friends. So, I mean, I want you to be always giving the right answer. And you did give a right answer. If you said first, it is faster. You could say second, it's faster. Now, okay, now this is a valid question. Why? Okay, I'll answer you why. But you guys have to promise me that you will see this entire presentation at till end of it. And if you want to see similar presentations, I've done it. If you go to IDERA's website, there's a resource section. I have a lot of other webinars there as well. I want you guys to see and learn from there also. This is great, but definitely check it out, my previous presentations as well. I think theirs were fun as well. Now, let's see the why. Okay, the why is pretty straightforward. That is because data type precedence, and here is the link. If you want, you can just remember the word data type precedence. The way the SQL Server works is every time it comes across any string compared to integer, then it will always convert string to integer. There are many different data types, but this is the primary logic it follows. String is always converted to integer. That's why when this was string, the entire column was converted. All the 10,000 rows were converted. All the 10,000 rows were converted and then compared to this integer. That's why this was super expensive. But now this is integer. So integer to integer. And this is also integer. But integer won't be converted to string. Always string is converted. So there is only one conversion from here to there. And that's why both of them are going to give you equivalent performance. This is because of data type precedence, and there is no implicit conversion going on, and seek 1 and 1. So yeah, it is important that when we are working with SQL Server, we know the internals detailing about it. But now, this kind of detailing, you can only know if you have a query. Did you like this demo? Just say yes or no, so at least I know your feedback. So um, this is how you can tune your queries and know about it. Thank you very much. But this is only about one query. How do you monitor more queries, thousands of parallel queries, so many things going on in your system? How do you do all this kind of thing so efficiently when you are new in your job or when you are experienced in your job? You want those thousands queries and this kind of problem surface to you. You need to have right monitoring system place in your organization. And that's exactly where the next thing comes in. That's my friend David is going to explain you how you can monitor lot of cool thing and how you can manage your organization's multiple SQL servers. So over to you guys, over to you, David and David. Thank you guys. And I will answer all the questions which I have not answered so far.
Thank you, guys. So my name is David Terry. I'm with IDERA. I'm one of the sales engineers on the SQL Server side, and hopefully you guys can see my screen. So what we can offer to help you better kind of tune and understand where to go tune queries is a product called SQL Diagnostic Manager, which is a fantastic tool that's built from the ground up to monitor Microsoft SQL Server environments, and it is enterprise class. So you can monitor thousands of SQL servers all within a single pane of glass, giving you all the information you need to know about how your SQL servers have behaved, not only in real time, but one of the beautiful things about this tool is that it gives you a lot of access to history. As we all know, we don't often have the ability to go look at our SQL servers in real time to see where the problems are coming from. So a tool like Diagnostic Manager in-house can really give you some opportunities after the fact to identify where those bottlenecks are. And there's different ways that you can do this. SQL Diagnostic Manager is very, very comprehensive, so it's not just looking at queries. It's looking at all different aspects of how SQL Server is behaving, including in some aspects of how virtualization may be affecting overall SQL Server performance. And there are different approaches that you can take. I will give you a hint. Kind of the main way that I use this product is looking at alerting, right? So if I'm monitoring hundreds or thousands of SQL servers, or monitoring two for that matter, I don't necessarily want to have to hunt and peck and try to find problems. That's where a tool like this alert facility can really help you out, right? So I can drill in directly, look and see what alerts are being activated on each one of my individual SQL Server instances, and then use that to drill in. But there's other ways to do that as well, right? There's anecdotal information that comes in from users indicating that there may be performance issues. That's not always as complete as you would like. So one of the views that I really like to use in SQL Diagnostic Manager under the Queries tab is the weights view. So being able to understand what the SQL Server performance looks like over time by using weights. And then from there, I can start drilling into the queries that we've discovered within the weights. There's different ways to approach this, but let me give you an idea of what I'm talking about. So right now, I'm looking at this production one server's weight statistics over the last hour. And an hour may not be enough data. So maybe I'm going to transfer up here at the top from 1 hour, let's go to 8 hours. So if I go look at the last 8 hours worth of data, we start seeing some unusual activity that happened earlier this morning. If I drill into one of these slices of time, right, we can start seeing, all right, well, these were the weight statistics that we picked up at that in that time frame. If I go look at the statements that were picked up in that time frame, the pink stuff is at the top of the list. So if I look at this from a text perspective, this particular insert has been causing me the most pain, at least within this window of time. So sometimes you don't necessarily know what you're looking for, and you want to step back and kind of look at the forest and then drill down to those individual trees and pull the statements out that you may want to go investigate further, right? The next step in that process is probably looking at the individual queries themselves. So again, under the Queries tab, if I go look at something like statement mode, and I'm going to expand this out a little bit more. I'm going to reset this filter to look at the basically from midnight till now. So if I'm looking at a big bucket of queries, if I can get this guy to refresh. Oh, did I not do that? I probably did. There we go. so this will take a second to refresh. But nevertheless, when I'm looking at these queries, right, I'm going to sort by CPU time here. So what are we looking for, right? So that select query that we were just looking at, or the insert, excuse me, that we were just looking at is popping up in this list as well. So there's different ways that I can identify. It happened to not be the worst performing query on my system from midnight till now. It was in that little slice of time, but I can identify where these queries are coming from. And I have just general statistics, which queries are running the longest, which ones are using the most CPU, the most IO per seconds, right? So different types of IO are visible. When did they start? When did they end? What was the statement that ran? So I have these nice lists that I can choose from. But before I go there, it may be even better for me to look at these queries organized into blocks. So again, right now what I'm trying to do is identify where are these queries that we need to go tune, which queries need work, which ones are poor behaving. And one of the criteria I personally use to identify where I'm going to go first for tuning is looking at the frequency that these guys are running that are running poorly, right? So if I have a query that runs once a week and it's it's set up as varchar versus integer, and I have weird things happening as far as IO goes, maybe I don't care so much about that guy that's only happening once a week. What I'm maybe more interested in tuning is something that's running more frequently, right? So the signature mode view under the queries in SQL Diagnostic Manager will group these guys together into what we call occurrences so that you can see the most frequent poor performing queries, right? So this guy here was captured 44 different times today with an average duration of 26 seconds. I can then take that average, right, and then drill into the query history. And when I'm viewing this query history now, we can see the same query, all the individual runs of that specific query. And what I'm noticing in here, at least, is that sometimes this guy's less than a second duration, and then other times it's 285,000 seconds in duration, right? So if I sort by duration here, we can see quite a bit of really long-running queries. Now, this is not the same kind of use cases as what we discussed in the webinar today. This happens to be some blocking, which is a whole nother story. But nevertheless, you can kind of see how this thing is changing over time. Charting, for example, how CPUs change, not very much. This is a select statement that we're running, so let's look at what the reads look like. So the reads are pretty much identical across the board. The only difference here is that it's getting longer and longer and longer. The reality, again, is if I drop over here and look at the blocking screen, we can see that stair-stepping we saw in the query performance is basically replicated here in the blocking tree. And I could drill into that guy and get a little bit more detail. All right, so at 7:50 this morning, we were seeing 82 blocking 89. So that's, again, a little bit different use case. But nevertheless, you have that opportunity in SQL DM to do that kind of stuff. And if you're looking at the query history mode, let me go back to that exact example so that we have, is that the select? Yeah, that one will work, but let's do this as well. So we'll go back to that same view, right? I'm looking at all those different queries and how they behaved over time. If I wanted to get in and look at something like the execution plan for that specific run of that specific query, I can do that as well. So if I need to pull up, 3 different queries, 3 different execution plans, what's the difference between this guy here and what's the difference between this guy here, right? We can pull, actually not text, I want to see the query execution plan here, right? We have both of them. And you can always export these guys out as just raw XML. You can view the text, you can see the columns. So a lot of good data there. So again, the general idea is that SQL DM is sitting in the background watching all the time, collecting this important data for you so that not only in the real time, but after the fact, you have the resources available to identify those bottlenecks and kind of correct them. I will also show you one quick little thing that was mentioned earlier, compatibility level. So, I said that SQL DM is collecting and storing a lot of different information for you so that you have everything at your fingertips at one time. And in Management Studio, obviously, you can right-click on the DB, go look at the properties, understand what compatibility level is. And if you have hundreds of databases, that can take a lot of time. So this is a very simple concept, but because DM is capturing all this data and organizing it for you in a nice way, I can just select an instance and go click on Database Summary. And what that's going to show me is a lot of metrics around how these databases are structured, but one of the data points included is the compatibility level. So this happens to be a 2017 server, and most of my DBs are well, I'll say half of my DBs are 17, but we're also getting some 14s and 2012s in here as well. So being able to kind of quickly run through and say, oh, you're right, maybe I should try to switch this over to a newer compatibility level, get some of those new functionalities out of SQL Server. This is a great way to quickly visualize and understand that type of information. So SQL DM, lots of different areas that can help you with, not only in query performance and query tuning, but also just general kind of overall server health, understanding things like jobs, understanding things like logs, being able to drill into virtualization performance, as well as overall, just general query stuff is all available to you. And I did want to mention real quick, because I kind of started this conversation with the concept of alerts are your friends, there are a lot of different things that SQL Diagnostic Manager offers as far as alert responses, right? So once that alert is raised, what am I going to do about it? If you look under the actions response section of the tool, these are the different action providers that are available. So it may be that you just want to be emailed when something bad happens, but you can also go to the event log. You can send out SNMP traps. You can talk to SCOM. You can talk to ServiceNow. You can run remediative steps. So I could run a SQL script a job. I can run a command line script, a PowerShell command. There's a lot of really cool things that we can do with these alerts besides just notifying you that you have a problem. There is the potential with SQL Diagnostic Manager to use alerting to do kind of Band-Aid remediations is what I like to call them. It's not ultimately going to fix the underlying problem in the application of the database structure, but until we have the time to kind of get that into the development cycle and get that rolled out to production, maybe I can throw some Band-Aids on it to get us over that hump, right? So I don't want to take up too much of your time, but I did want to mention quickly that if this is attractive to you and you are interested in maybe taking a look at SQL Diagnostic Manager, it's very easy to play with, right? So you can come out to the IDERA website. It is on the main screen here. Just say start for free. If we're transitioning to a different tool to promote, you can always find it listed at the top middle of our products list because Diagnostic Manager is our #1 tool here at IDERA. If you download the software to do a trial, it comes preloaded with a 2-week 10 to 15 servers. I don't know if it has changed. I think it is 15 servers for 2-week trial. But the big thing there is it'll get you in contact with one of our account managers who would be happy to set up one-on-one demos with you guys, answer any technical questions, as well as help you with pricing. So please feel free to go out to the website, download these tools. We have lots of different products available to help you guys manage your SQL Server space, and I greatly appreciate your time. I will pass it back over to you guys.
Awesome. Thank you so much, Pinal, and thank you very much to David. I appreciate both of you taking your time out of your day to come here and present for us. I think there were a lot of great tips included here that will serve our viewers well. To our audience, I want to say thank you for attending our webinar. We hope it's been informative and helpful. A recording of this event will be made available shortly, and you should receive that via a link in your email. If you have any additional questions or you would like to speak to an IDERA representative, please don't hesitate to reach out to us. You can find a contact us page on our website as you see there. And yeah, I really hope that everyone has a great day ahead, and I hope that you all join us next time. Thanks all.
Thank you.
Thanks, everybody.